Hi, have you ever wanted to make something like this? Well, today I will show you how to create it from scratch. And the best part is you can make it react to your own emotion with any pictures you like. All you need to know is a bit of a Python knowledge and the basic understanding how to Jupyter Notebook works. Let's start by training our model. At first, we need to import some libraries in our project, and I highly recommend training your model on a GPU. To do that, just visit the official PyTorch website. I will put all links in the description and take the comment from field below. If you don't know your CUDA version, you can check it in console. To do that, just prompt this command. I have CUDA version 13, so I will download version for version 13. It's kinda heavyweight library, so give it 5 minutes to load it. Once that's done, it's time to decide which images you want to show and what emotions you will be using. I took some placeholder images and to upscale them using Sora. Next, we will create our config file. It shows which label is connected to which image. So I have this. Next, you will need to take pictures of yourself showing each emotions you picked, at least 50 photos per emotion to get good results. Now we will head over to Rebuflow, also link in the description. I will show you how to create a new project and label your images with the correct emotions. We need to choose name and at least one annotation group. We will add more later. We will pick object detection mode, so we will detect our emotion. Here we need to import our pictures which we will use. Now we will proceed to label our pictures. This is the important part. You need to outline the area that matters for your emotion. For example, I have the emotion anticipate. So I also outlined my hands. But for most other emotions, it's enough to outline only the face. Now that you are done, we need to split our pictures into training, test and validation sets. I chose 70% for training, 15% for testing and 15% for validation. I have already created my own pictures, 50 or more for each class. To create the dataset, we need to go to datasets and click create new dataset. Here is a lot of information, you can just copy what I have done, it will work the same way. But if you want to dive in, you can just read all about it in the internet. It's free information. And finally, our dataset is ready. To download our dataset, we press download dataset, of course, show download code only, continue, and copy paste it in our Jupyter notebook. After you paste that and run the cell, it will download our dataset into the working folder. Next, we need to write our database YAML file. This file looks like this. Here is 6 classes Here's passes to images, train, test, and validation. And now we can start training. I will put this code in the description so you can just paste it here. I am using 100 epochs, that a bit too much. You can use around 30 or 40 instead. It took me around 20 minutes and now we can see our results. I'm pretty happy with what I see, so let's proceed to create our Python script. So here we create first our main script.py and yeah, here that we need to import our libraries which we will use. We will use import torch just for fun um, from ultralytic import YOLO, yes. We don't need RoboFlow actually. Import CV2 and I will import my config file with all my information. And let's start by... Here we are opening the camera using OpenCV. The number inside the brackets in my case tells which camera to use. If you have only one camera you can set it to 0, but I write here source, but source it's not correct, it should be index, it's my problem. Yeah. Also we have our model, we'll use YOLO config model pass. Now we will put our model pass. Here's also I put model pass in small letters, which is not correct. And also my pass isn't right, it should be run, so detect, train, and afterward waits and best. After that, we initialize current image, which is image which we have now in our screen, and label. Label is what we get from our model. Next, we make simple cycle, and cycle has return and frame, and if not return, if not image, we break our cycle. If our camera returns a value, we will use that frame to predict their motion. We don't need to show the predictions right now, and the confidence level of 0.5 is fine. We will check every result in our results. We don't need that code now. For now, we need to check our boxes, which is our results. So boxes equal results dot boxes. And for box in boxes, we will have class ID and label. Class ID is number of ID which we have for our class, and label is name of our class. If you want to see the names of your classes, you can check them in the data file. In the config file, you need to include the class name and the matching image path. Now we want to check if our model detects anything, so we will display the image. Release the camera, close all windows. And if we want to stop the program, we will just press the letter Q. Alright, let's test what we have got. Like I mentioned before, it's not the source, it's actually the index. Yes. And yeah, one more my mistake I made incorrect path. Model pass not just runs, it's runs detect. Runs detect terrain weights. And yeah, my camera is working, but it's showing the raw frame from OpenCV, not the model's results. To fix that, we need to plot our results and display them with image show. And yeah, now it's working. So anticipate this sigma. What do I also have? I want a specific resolution for the collateral image, so I will add a dictionary in the config file which show my resolution. And now we will check if the current image don't equal the label what we have now, we will change our image and that's all. Alright, let's run it and see what we have got. And yeah, it's working and it's actually not tricky as you think. And to quit, just press Q. Nothing tricky about it. If you reach 100 likes, I will show you how to use those images in Discord to prank your friends. All the code will be on my GitHub. You can find the link in the description. Thanks for watching. If you want to ask me something, just write to me on my social media. I will be happy to reply. And that's all for today.